So I'm going to nibble on a number of topics here. So we'll come to our special morning class where we'll look at a few hiccup questions just to consolidate. So I'll look at ANOVA, regression, estimation, and sampling. So ANOVA basically, you need to understand how to balance it up to start with before you learn of anything. So to start with, ANOVA is about differences between treatments, which we call columns. So the treatment is a column. So in between here, we're going to have differences or variations. So we call this sum of square between. So I can give you maybe the sum of square between is 100. Then the treatments are the total number of columns that we have here, denoted by the letter K. The K here maybe is equal to 3. Then you could have observations. Maybe here there are 4, here there are also 4, and here there are 4. These entities or entries are called observations. And these treatments are called populations. So the total number of entries here is now 12. So these are called observations. And these observations have a sum of square total in terms of variations, maybe which is given by 181. So I'm going to give you a template of how the ANOVA table is drawn. So we draw the ANOVA table in terms of 3 sources of variations. So we have a source which is called between, a source which is called within. So these are the variations that are within here. We call them sum of square within. And we have the total variations that we have when we sum up the total variations in between. So here is called the sum of squares. This is called the degree of freedom. This is called the mean of squares. And this is called the F calculated. So here we call this sum of square between. Here we go sum of square within. Here we call it the sum of square total. And here it is K minus 1. Here it is N minus K. And here it's N minus 1. These are the formulas. So once you get to understand these formulas, you don't have any need to memorizing the whole formulas in ANOVA. This is your formula kit. So I will now use the same example that I've just done there to help do some balancing off. So this is an independent topic which doesn't require you to really study. We have between, within, and what? And the total. So let's go. Sum of square between, we've been given as what? 100. So we put 100 there. Sum of square total, we've been given as what? 181. We put it there. The difference between is sum of square within. So that is 81. 81, let me put it maybe in a different color. 81 because it's a difference which we calculated. Then here the degree of freedom is K minus 1. How many treatments we have there? 3. 3 minus 1, we get out 2. Then the degree of freedom for within is N minus K. Our N is 12, our K is 3. So 12 minus 3, we get a 9. Then we total here, we get 11. The mean is just divide these values here. 100 divided by 2 is 50. 9 into 81 is 9. Then the final answer here, final divide here. That's all. 9 into 50. What do we get? 9 into 50, what do we get? So 50 divided by 9, we get 5.55. So they ask you, how many populations are these? You just add a 1 there. There are 3 populations. How many of observations are these? You just add a 1 there. So that is how we find and balance up that table. Are we together so far?
Yes.
So it makes a lot of sense. When you understand how to balance up that.
That's the question.
So now I'll take you through.
Collins, I've got a question.
Yes, please.
Last time I asked you the same question again, I want to ask. For that one, like the way Mr. Sabao solved it, when you're not given those, when you're not given the sum of square, just
Okay.
given the, like that one between the T2, T3, T1, T2, T3, they give you like on T1 there's 4, 5, 6, on T2 there's 7, whatever, all those numbers. Do you use the other formula, the one that you just put there, T1, T2, T3, like the one that Mr. Sabao used?
Okay, so if you're not given these figures there, so we have T1, T2, and T3. You need to calculate the figures on your own. 2, 3, 1, 1, 2, 1, 2, 2, 1. So let's calculate together. So let's sum up them up here. What is the total here? 6. What is the total here? 4.
4,
What is the total here? 5.
5.
Then the total here is what? 15. How many are there here? Then here is what? 3, 3, 3. The totals of this observation is what? 9.
9.
And you square them individually. 2 squared is 4. 3 squared is 9. 1 squared. So this is what? 14. Then here we have what? 4, 5, 6.
6.
Then here we have 4,
9.
1, which is 9. Then sum of x squared here, what are we going to get? 29. All right. Then the sum of square total has a formula, which is given by summation of x squared minus summation of x to the power 2 over n. So here we're going to have what? 29 minus 15 squared over what? Over 9. All right, what do we get?
Uh, 25. 25.
So this would be 29 minus 25 will give us what? 4, right?
Yes.
Then we go to sum of square treatment, which is the sum of square between. So we're going to sum the treatments minus the correction term. So what does it mean? We go individually. 6 squared over 3, 4 squared over 3, 5 squared over 3. So 6 squared over 3 plus 4 squared over 3 plus 5 squared over 3 minus what? 15 squared over 3 over 9. So What are we getting there? 6 squared over 3. 6 times 6.
12.
Divided by 3.
It's going to be 12.
12, Then 4 times 4. Divided by 3. 5.33.
5.3.
And 5 times 5. Divided by 3. 8.3.
8.3.
Then minus what? 0.5 this side.
It's 25.6.
5.66
Yes.
minus 25.
Which is 0.633.
0.66. All right. So this is called the sum of square what? Between. Now, what information do we need from this data to balance up? The K. What is our K? The number of treatments. How many treatments do we have?
3.
3. What is our N? The number of observations. What do we have?
9.
9. What is the number square between? We just calculated is what? 0.66.
0.66.
And the sum of square total is what?
4.
It's 4. So we can balance this now up, right? So let's go now to our table. We have 3 sources of variation. We have SS, degree of freedom, mean of squares, and F calculated. So between, within, and total. We just calculated our between as 0.66 and our within as 4. Can you help me balance up this? How do we get within?
We subtract the 4 from the 0. We subtract 0.66 from 4.
Okay. How do we get?
Three point three four.
3 point?
4.
3 4.
Okay. Then here, what do we get?
Two. For between it's 2. K minus 1.
So K minus 1 is 2.
And N minus K.
And the other one is 6.
Are we using the big N when subtracting or the small one?
The big one. So what do we get here and what we get there, yeah?
6.
N
6.
minus K is 6.
So our N is what? 9. 9 minus 1?
8.
Minus 3.
And subtract 8 minus 2 is 6. All right. Then how do we get this column?
Divide the sum of squares by the degree of freedom into the sum of squares.
We're dividing like that, yes.
Mhm. So 0.33
Mhm.
for the between.
And 0.556 for the within.
Yes.
So here it was what? N minus K, 3, N minus 1, 3 minus 1 is 2. N minus K, 9 minus 3 is 6. N minus 1, 8 minus 1 is 8. Then let's divide this in there and this in there. What are we getting?
0.34 and 0.556. 0.56.
So 0.33, 0.56. Then how do we get the F calculated here?
We would divide 0.33 of 0.56 into 0.33.
This in there, what do we get?
And 0.33 divided by 0.56.
Mm-hmm.
0.58.
0.58. Okay, then we can conduct a hypothesis test. So HO, simply say mu1 is equal to mu2 is equal to mu3. Yes, at least one is different. Step 2, we set the level of significance, which is usually 5%, if not given. Then step 4, step 3, you read the F table. For 5%, the reason why we need the degree of freedom is to read the tables. This is 2,6. So let's go to the statistical tables and look for 5%, 2,6. All right. %, 2,6. Do we have our tables there? Okay. So when you go to the table, it's one of the last tables at the end. 5%, so 2,6. What is the reading? Can you see? The 5% table, then 2 and 6, 5.14. So when you go here, 5.14, this is the F table. And the decision is always, we reject if the F calculated is greater than that. If it's small, we accept or fail to reject. So this is smaller than that. What do we do? We fail to reject. Or the other term for fail to reject is to accept. If we had 5.8, we would have rejected. So you can draw. This one is usually it's a single tailed. It's usually one side here. There's nothing like double tailed. It's just on this side. So here it's accept region. Here it's a rejection region. Then step 4, we calculate the F calculated, which is already in the table, which is 0.58. Then step 5, we make a decision. Accept HO. When you accept HO, it means there's no statistical significance or difference. No difference in short. When we reject,
Okay.
there's a significant difference. On what? Based on the hypothesis here. So here it means the mean 1, mean 2. There's no difference in these means of the treatment. When you reject HO, it means you're accepting HH. So one of them is statistically different. So here our F calculated was 0.58 against a 5.15. So in this case, you can confidently say that there was no statistical difference. Now I can allow for questions.
Yes,
Mr.
Colin,
Collins,
I
what
just
that?
want. Okay, you
Sorry.
can go then. I'll ask.
What's that writing under H1?
At least one is different.
Sorry.
At least one is different.
All right. Okay.
Then what I want to know is just get back to how we got to the F table from more.
2, 6. So if you're given the F as 5%, there are 3 F tables that you have. One table is the 5% table. It has 2 pages, it continues. The other table is what? The 1% table. Then the other one is 0.1 table. So we particular with the alpha you're given. Usually gives 0.05. So 0.05 is 5%. That's a reason for the degree of freedom. That's a function of the degree of freedom. So 5% table. The degree of freedom for the between was what? 2, within was 6. So you go where they meet 2 and 6. That is how we got that figure there.
Oh, okay.
Any other questions? So ANOVA is the easiest. I want us to try the question Dr. Sabana did in class.
Freedom.
Any questions before I proceed? Can somebody post the question that Dr. Sabao did in class? Let me look at it. Now, I must mention that I don't have a calculator with me. So if you're not going to participate in calculating, then we'll waste a lot of time. So I've sent it just now. I hope you've seen it. So we can now attempt to answer that one together. Let me beam it so that we move together. Okay. So have you seen the question?
Yes.
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 So this question most likely may come, but you'll be given the totals that are similar given, so that we can work with the worst case scenario. So what we do first, that's a scenario. Help me identify the K and the N first of all. What is the K and what is the N?
Okay, is 3.
What is the N?
Oh, n is 9.
How are you getting the 9?
Oh no, wait. Our
18.
18.
18.
Our K is 18.
Please don't make
K
such
is
mistake in the
no,
exam.
n is 18.
As you write these exams, don't think about yourselves only, think about me. I'm serious about that. I thrive on the numbers that do well, so I would need to be very strict. Don't make mistakes like this. Okay. N minus K is what?
15.
15.
And N minus 1 is what?
And what?
N minus 1.
17.
Okay, so let's total up here. What is our total here?
30. 27. Next
Mhm.
one. The last one is 36.
And how many are there in each? 6, 6, 6.
6, 6, 6.
And here, what is the total? Square total. Others must be verifying.
$154 for the first one.
Okay.
$123 for the second one.
218 for the third
Up. Total up. This plus that plus that. This plus that plus that. What are you getting?
93.
The last one is 495.
95.
Are we all following, or just 3 people that understand what I'm saying?
We are following.
We just don't have our calculators.
Okay, so some of please calculations like these ones. By the way, I'm the best tutor when it comes to online classes. It's like you're in class. Okay, so I need you to come with a calculator so that you move as though you're in the physical class. So it will make a lot of sense. You come with your tables and calculators and assume you're in class so that you follow. It makes sense as you do the calculations. Okay, so 495. Let's find the sum of square total. What do we get here?
14.5.
3.5. And how do you find the sum of square between? What's the formula?
Summation of treatment squared divided by small n minus in bracket summation x squared over n.
Within its area, not
Yes, within its error. So what do we get as the final answer here?
seven.
7. So what is the sum of square error? Total minus what? 3.
Mhm.
So 14.5 minus 7, what do we get?
7.5.
So let's set up the ANOVA table. We have 3 sources of variation. What are the sources? Between, within, and total. So what is the sum of square between?
7
And what is the sum of square
within 14.5.
within? So here we have what?
7
7 total
14.5.
within.
7.5.
What was our K? So we already calculated K minus 1 is what? 2, n minus K 15, then 17. 2, 15, 17. 2, 15, and 17.
7
The mean, what are we doing? We're dividing this and this and there. What are we getting?
3.5.
And here,
0.5
and if calculated here, then the degree of freedom, what is our coordinate?
2,15
And why are we reading at 5%? What were we given as our alpha?
0.05
So 5%, can somebody read for us here? 5% under 15. That is 5%, 2 comma what? 2,15. What is our reading?
3.68.
Do you all agree?
Yes.
yes
3.8. What is step 1 of hypothesis testing? So this is 3.68. What is our decision here? So I've improvised a table so you don't lose the marks. I've added 2 columns. If tabulated, you write the decision there is what? Are we rejecting or we failing to reject?
We reject.
We are rejecting.
Because it's more than that. If it was 3 here, we'd have what? Accepted, right? So let's conduct a test. Everything has been done in the table. Just for formalities. For me, I'm very systematic. mu1 is equal to mu2 is equal to mu3. Yes, at least what? 1 is different. That's step 1. Step 2, set the level of significance. So level of significance is what? 5%.
0.5 5%.
Or alpha 0.05 is the same, huh? And step 3, set the decision rule. We reject HO if what? So reject HO if Z calculated, if F calculated is greater than what? 3.68. Step 4, calculate the F calculated, which is what? 7. Step 5, make a decision in conclusion. It says since F calculated, which is 7, is greater than 3.68 at the level of significance 5%. What do we conclude? We reject what? HO and conclude that there's a significant statistical difference. There is a significant difference among the means. Isn't this interesting? Among the 3 means. So I have answered it awesomely, completely, and conclusively. All right. Any question?
I'm currently asking that you post this on so that we revise through again.
All right, I'll do so. All the morning videos are posted in the exam books. So we now go to sampling and estimation.
Okay.
So sampling, need to understand that there's the song we have spent. We have 99% and 8% and what? 95% and 90%. The difference is 1, 2, 5, and what?
10.
0.01, 0.02, 0.05, and what? 0.10. Then here for a two-tailed test, it's 2.58, 2.33, 1.96, and 1.645. In my class, you know what I'm talking about. If it's a single-tailed test, 2.33, 2.05, 1.645, and 1.28. This is for a single-tailed. The signs for a double-tailed test is equal to or not equal to. Here it's greater or less than. So, estimation and sampling, it is always a two-tailed. The formulas under estimation, confidence interval is what? Mean plus minus Z, standard deviation of root n. I usually avoid putting this alpha over 2 because people become overzealous. They answer and divide your answer by 2. Don't do that. For proportion, it's the same. P plus minus Z, PQ over Q over N. And the sample size is simply given by Z, S over A. And you square everything. Or Z, PQ over A. Then you square everything here. All right. So you must understand that confidence interval is simply the difference between the mean and the what? The margin of error. So this code is called the standard error. Standard error is simply standard deviation over square root of n. Margin of error is simply Z standard deviation over square root of n. That's our own fact knowledge. So, sorry, just to explain a few concepts. If you're asked to find a 95% confidence interval for a mean of 10, and you're given standard deviation is 12, and our n is 36. How do you find this? Confidence interval using the formula is equal to mean, which is 10, plus minus z at 95% is 1.96. And standard deviation is 12 over square root of n, which is 36. What is our standard error? Our standard error is 2. Hope you understand what I mean by standard error by now. This part is standard error. What is our margin of error?
I am.
Margin of error,
You didn't.
please mute yourselves.
Oh.
Margin of error is what? 3.92. When you apply these two. So here we'll subtract and we'll add. So this is called our confidence interval. What is the difference between a point estimate and the confidence interval? What is the difference between a point estimate and a confidence interval? Anyone? So you must always be able to balance up your knowledge in calculation and also your knowledge in the theoretical part, so that you don't lose marks, because these questions will be what? They'll be palanga shaped. All right. I want A is this intake. I'm angry because certain mistakes that I made, maybe I was not overemphasizing for some people last year. So this year, or this intake, I'm very angry for some of the mistakes. I think I'm blaming myself for not overemphasizing. So let me put it here. The point estimate and the confidence interval are both statistical measures that are used to make inferences about the population. However, they convey different information. A point estimate is simply a single value calculated from the sample data that serves best estimate for an unknown population, e.g. the mean standard deviation. It is a specific number which represents a central tendency. So here, this is a very good explanation. So point estimates do not convey. And confidence interval, on the other hand, provides a range of values within which the true population parameter will fall. You know how to summarize that. All right, are we together? So point estimate is a single value. Confidence interval is a range of values. In other words. All right. So find a 98% confidence interval given a variance of what? 144. Given a variance of 144. Okay, a sample size of 36. And a mean of 10. So who wants to try that? Mean plus minus z, standard deviation over root n. So our mean is what? 10 plus minus. If you're given variance, if you want, you can simply say z variance over n, and it's correct. Okay.
Collins, are you able to mute mic?
Yes, please. If the variance is 144, I don't know how people are sensitive of their backgrounds when they join. All right. So are we together at that point? Any questions?
Yes, sir.
Yes, yes. Anyone to finish up that question? So subtract, what are you getting? What are you getting when you subtract?
Uh, 5.34.
So sometimes you'll be given proportions. Find a 95% confidence interval for the proportion that has been given. So who has the May paper? Please send the May paper for last year. So if our proportion is 20%, meaning the Q should be 80% or 0.8. So you should understand what I'm doing here from what I've just explained. Okay. So what are we going to have there? What are you having? What is our standard error? What is our standard error?
Zero point 0.0845. Is it?
0.0845. Then you multiply, what is our margin of error?
Zero point 16579.
So what is the lower bound?
0.0342.
And the upper bound?
0.657.
So this is 3.42%. This was 36.5%. All right. Are we together? So sometimes you may be given a big sample, 50, and a small sample, 8, and you're asked to find a 98% confidence interval. So the proportion here is simply small sample over big sample. So 30 over 50 is what? 60%, meaning what is our Q? 40%, right? So here we're going to have 0.6 plus minus 2.33 square root of what? 0.6 times 0.4 over n, which is 50. Sample size. So for sample size, we have what? Two formulas, z squared, s squared over e. The examiner will be very direct to ask you what sample size is required. If your alpha is 0.05 and your standard deviation is maybe 3, and your error is within plus minus what? 4. So let's just substitute here. What is our z? 1.96. Our standard deviation, 3 squared. Our error, 4 squared. And your answer. Suppose we're given alpha 0.02, our p 10%, within 0.05, within 5%. So what do you do? Our n therefore will be z squared pq over error squared. So our z is 2.33, our p is 10%, our q is 90%, and our error is 5%. So 0.05. So you put a square here and the square there, and you answer. Are we together so far on what I've explained? So sample size is important, but under sample size, there are follow-up questions that you'll be asked. You'll be asked to explain the types. What is sampling error? Okay. What is sampling error? What are the types of samples? What is sampling error? Anyone? I explained this. This question has always been coming. Okay. What is sampling error? So sampling error is defined in many ways. So it simply is the difference between the sample statistic, such as a mean or sample proportion, and the true parameter, like a population mean and the population proportion. So it arises due to using a subset sample of the population instead of the entire population. So sampling error usually occurs because a sample may not perfectly represent the entire population because of the sampling process. So that is what we call sampling error. So there are different types of sampling that you need to know. Broadly, these ones could be into two. There's a probability and non-probability sampling method. So I gave you the 10 types of sampling. Each of them has a particular method. So let me just give you some notes that I gave you last time. Okay. So we have two types of sampling of what we call probability sampling. Here, in this type of sampling, each member has a known probability. So we have what we call simple random sampling, where each member has an equal chance of being selected. Systematic sampling, where members are selected at regular intervals, like every 10th, every 9th, every the 90th percentile. We have the stratified sampling, where the population is divided into homogeneous subgroups, which we call strata, based on specific characteristics. Then the sample is drawn from each of those strata. Okay. We also have what we call cluster sampling, where the population is divided into cluster subgroups. And these subgroups, you select a simple random sample from there, and all the members within the clusters will be included. Then we also have the non-probability sampling methods. Non-probability sampling methods, which we discussed the other time. What are the non-probability sampling methods? We just enlist them here. So the non-probability sampling methods require some sampling process where we don't necessarily need to choose a probability. It is subjective and does not allow generalization to the larger results. So some of the common types of this sampling include the following. We have what we call convenience sampling, where the population is based on accessibility. For instance, you're doing a case of Unilath. We also have what we call purposive sampling method, where each researcher selects a member on their expert judgment. It's also called judgment sampling. We're targeting specific individuals who you have considered to be representative and informative. For instance, the impact of COVID on breathing. You only ask those who have experienced COVID. We also have what we call quota sampling, where the researcher selects a sample that meets the predetermined quotas. For instance, specific population, only the males, gender between 8 and 15, ethnicity, those that are Tongas or Pembas or Nyanjas, but don't use a random sample. We have snowball sampling, where you are going to pick a small number of people first, then they'll refer to individuals like a snow grows into a big ball. So this one is always used when there's hidden information or hidden populations, so that you're able to find out who does what. All right. For instance, when policemen are investigating who stole what, they'll ask you who your friends are. The advantages and disadvantages of these methods can also be studied at your own time. Is this helpful? Are we
Yes, sir.
getting somewhere? So in the exam group, let me send the notes so at your own time. I may not have all the time to write all these notes. I think that's why I love the online classes. And I could just sit here the whole day and teach everyone online. I would cover so much than the physical. All right. So I've sent you the notes in the exam group. I hope you've seen them. Okay, you've received them?
Yes, you've seen them.
Okay. I also send you the first one on point estimate. Okay. So please, I have finished the Qm Bible for your sake. The reason why I'm angry is that I'm trying to emphasize points and people are taking it casually when they make mistakes. It's also on me. So please read all these. All right. So we can now proceed.
Just a question. These recordings, you put them on YouTube or just on the group?
I'll put them on the group.
Okay.
Yeah. All right. So now let's go to hypothesis testing. I don't know whether we should look at Dr. Sabao's questions for now, or we go to hypothesis testing. I'm supposed to be with you up to 8 hours. I only have 20 minutes. So I've explained the song, the sampling method, and also how to define sampling error, the types of samples. You'll need to know the advantages and disadvantages of each. So let's look at some questions from Dr. Sabao's paper. Problem is I need to crop it and send it to the PDF for us to see. I hope you've seen other questions. So let's look at question number activity 3. Activity 3. Shiluba, are you there?
Yes, I am.
All right. Activity 3. Is on sampling. So I require you to look at it. Sampling. Let me beam it here for you to see. Activity 3. So what are we given there?
Our mean is 425.1. Our N is 20. And standard deviation is 9.8 at 95% confidence.
There's no volume, or it's just me, or it's up on my end.
So I was saying in this case, we have an 5% confidence interval. We're given N20, X bar 421, 25.1, and standard deviation at 2.8, find a 95% confidence interval. So when you use this formula, we know the formula. I was saying we don't need this. You guys already know the sum. So our mean is 21.1. Our Z is this, and our standard deviation is 92.8. So calculate that. Okay, in the interest of time, let's consider a random sample of 20 paperback novels that average 421 pages in length. Assume the count for all paperback novels are distributed with some division to 9.8. Calculate 95% confidence interval, calculate 99% confidence interval, calculate the minimum sample needed to identify a 98% confidence interval for the mean, assuming the margin of error is 52 pages. So this exact question that is coming, it just nibbled it. So let's look at the miracle kit. 95% confidence interval, so meaning our Z is 1.96. Okay, we're given how to find the what? How do we find the 95% confidence interval? So confidence interval is what? Mean plus minus Z S over square root of N. So our mean is what? Our mean is 425.1. Our Z is what? 1.96. Our standard deviation is what? 92.8. And our N is what?
20.
N is 20. So when you calculate that for 25.1, this collectively is called the margin of error. So the margin of error we're getting is what?
40.67.
40.67, correct. So 40.67. And the lower bound what?
384.43.
384.43. And the upper bound?
465.77.
65.77. So this is how we do that. So this is a solution. 384.43 and 465.77. How about find N90? N90 part B, find a 99% confidence interval. The same, 99 is 2.575 or other side 78 is okay. If I get the margin of error, which is 93, then you use mean plus minus error, you get 371 and 378. I hope you're understanding what I'm saying. then calculate the minimum sample size needed. So here we're being asked for what? N. Okay, how do you find N? Remember, as N is got what? Z squared, S squared over what? E squared. So what are we given here? Our Z is what? 2.33. All right, our standard deviation has already been given as what? 2.8. Our error is what? 52 squared. So when you calculate that, you're going to find 17.23 or 18 approximately. So this is there in our miracle kit. So this is N is Z squared times, so it's 2.33. Are we making sense of, our lesson?
Yes, sir.
Yes,
This
yes.
miracle kit, do I have it? I don't think I have it.
I'll send you.
Okay, sir,
Okay.
thank you.
Any
Even me, I don't have it. Is it the one you posted in the group?
Yes, I think I posted already. All right, but I'll send it again. Let's look at this other question.
Hello, give me my
Question number, please don't sing in class. All right. So let's look at question number, a formal. You've seen that question? A formal wear store. Have you seen that question? Have you seen the question that I've sent on the group?
Yes. Yes.
Okay. So that is, I'm trying to refer to those ones that you see that these questions are not coming from anywhere else but his questions. We're not getting these questions from anywhere else. They're his questions. All right. So we can go to the miracle kit. Or let's discuss it just here. All right. Let me paste it here. Okay. Can somebody read the question for us? Shilva, you can.
A formal
Okay.
warehouse store determines that its customer population has a maximum age of 27 years and, a formal warehouse store determines that its customer population has a minimum age of 27 years and a maximum age of 62 years. What is the minimum sample size needed to calculate a 90% confidence interval for the mean age of its customers, assuming a margin of error of 1 year?
Okay. So let us identify our parameters. What are we given there? We're given, what are we given? So we're calculating what? The minimum sample size, our N. N is equal to Z squared, S squared over what? E squared. What is our Z? 1.645, right? Are we together on the Z?
Yes.
Yes.
Then what is our range? Maximum high value minus low value. Okay. What is our range? High value minus low value. What is that?
62 minus 27.
What do we get? 62 minus 27, what do we get?
35.
35. Right. So to get our standard deviation, we divide the range by 4. 4 is just a standard figure. So standard deviation is what? Range of
Mr. Collins, is it 4 or 6?
it's 4.
Professor Paul gave us 6.
Even last time when we met at Yonza, Mr. Collins, you gave us 6.
Oh, 6.
And Doc gave us 6. Yes.
Oh yeah, it's 6. So divide by 6, what are you getting? If you're given a range, divide by 6.
5.83.
What are we getting?
5.83.
5.83.
Mm.
Now together, all of us.
Yes, sir.
Then are we given the margin of error?
Yes, 1.
1 in terms of months, because we're dealing with months. So our margin of error is what? 12, right? All right. Well,
Come again on that one. On the margin of error. The explanation why we're getting 12.
so 1 year is the same as what? 12 months. Okay.
So before we move, do we always convert to months or does this particular one require to convert to months?
Okay. First of all, did he solve this question in class?
Yes, he did.
Okay, what did he use? Did he use 1 year or he used 12 months?
Let me just go back to my notes. I think he used 1.
Okay,
Unless I'm wrong, but I remember he used 1.
he used 1. Okay, all right.
Mhm.
All right, okay.
He used 1, yes.
Then what is the error? 35/6, what did he get? And the standard deviation, what did we get? 35/6, which is what?
Sorry, 5.83.
5.83. And what is the final answer? What did you get? What's the final answer? Quickly, so to remove something else.
Okay, I'm getting 36.6.
It's 6 points. All right. That is the answer, 36.6. All right.
But the answer, I remember, Mr. Collins, it was 91.5, and then we rounded it up to 92. But I'm just trying to find where I had written it down when we had solved it with Doc.
All right, okay.
I remember the answer was a 91.5, and then we rounded it off to 92.
All right, okay. It was 91.15.
91, yes.
0.51.
Or 51, yes.
Is that what we're getting when we do this?
So you people use Swaziland.
It's either you use 1.64 here. So it's the same thing. But what are you getting like this? What are you getting?
Okay, so Mr. Collins, I found it.
Mm-hmm.
So after we got the 5.833 squared, we squared the 5.833, and then we multiplied it times 1.64, and we divided it by 1. So it should give us 91.5.
Yes, so I'm
The way
saying.
we have, yes.
So sometimes he likes to use 1.64. You remove the 5 there, but the answer is still within the range.
Yes.
So Collins, I'm a little behind. How have we found the 5.83?
I said the range is when you divide the range divided by 6.
Okay.
Your standard deviation. All right.
Yes.
So that is some information you needed to know. All right. Are we together?
Yes.
All right. So anyone else behind? All right. So let's look at another question from the list. Let's look at another question from the list. I've sent question number D, 10% of the machines. Have you seen it? Have you seen it?
Where have you sent it, Mr. Collins?
On the exam group?
Oh, okay.
Can somebody read it?
I think some of us are not in the exam group. Can just maybe post it in the other group.
Yeah. It's there in the miracle kit. Just check it. Let me post it again. So this is the question we are looking at. Can somebody read it?
%10 of machines produced by company A are defective, and 5% of those produced by company B are defective. A random sample of 250 machines is taken from company A and a random sample of 300 machines from company B. What is the probability that the difference in the sample proportion is less than or equal to 0.02?
Okay. So what are we given in this question? Let's identify the parameters. What are we given in this question? What are the parameters in here? Did you solve this question as well?
No, he didn't.
All right, so what are we given in this question? We're dealing with proportions first of all here. We're looking at the difference in sample proportions. So I hope he taught the differences in sample proportions. So that we move together. Difference in sample proportions. So just identify anything that we've been given there that you're able to identify. Let's start from there. What are we able to identify from there? At least you must be able to identify something.
So I think our Q is 0.02. I don't know. Then our P is 80, 0.08.
Isn't it not the opposite?
Or the
P is
opposite?
supposed to be 0.02.
There's P1 and P2 there. So which one is P1 and which one is P2? Yes, you're right. Just those are not Qs. There's just P1 and P2.
So the 10% and the 5%?
Yes. So the formula for a difference between two means is given by what formula? Okay. So we must understand one thing, that we're looking at the difference between two populations or two proportions. So let's go to the miracle kit so to just understand the breakdown of so this is our question we're looking at. %10 of machines produced by machine A are defective, and 5% of those machine B are defective. A has a random sample of 250 machines and taken from company A and random sample of 300 machine B. What is the probability that the difference in sample proportion is less than or equal to 0.02? Okay, so the difference between means P1 minus P2. Okay, so we have 5% and 10%. So this is a formula that we use when you're calculating the standard deviation of the difference between two proportions. So this is P1 times 1 minus P1 over N, sample 1, P2 times 1 minus P2 over N for sample 2. So we must what's the probability that they are less than 0.02. So the difference must be less than 0.02. P1 minus P2 must be less or equal to 0.02. So here what we do, we subtract the differences P1 minus P2. So 10% minus 5% is 0.05. So I'm using the formula that I gave you there, 10% over 0.90 over the sample size, which is 250. And 0.05 minus 1 minus a proportion, which is 0.95 over 300. So we're going to get approximately 0.0275. So here the Z, we subtract 0.02 minus 0.05 over what we just got in here, 0.0274. We get negative 1.09, which is approximately negative 1.10. When you read this from the table, negative 1.10, it's about 0.1379. So if you're using a positive Z table, you subtract your answer from 1, then you get this proportion. I'll discuss this at length in the physical class, but for now, just for the sake of the record, this is how you look at it. Okay, let me go to hypothesis testing. Sorry, I'm dominating so much on this because I haven't had enough time for the QM online, and we don't have class today in the evening. So let me cover at least the topics that I wanted to cover for the week. Hypothesis testing, then I'll end here. So for hypothesis testing, confidence level, Z for a two-tailed and Z for a single-tailed. We have 99%, we have 98%, we have what? 95%, and we have 90%. The single-tailed test is 2.58, 2.33, 1.96, 1.645. And here we have what? 2.33. And here we have what? 2.05, 645, and what? Finally, 1.28. The sign here is greater or less, is equal to or not equal to. So the steps for hypothesis testing: number 1, we state the hypothesis HO and H1. Step 2, we set a significance level. Step 3, set the decision rule. Step 4, we calculate what? The Z, which is X bar plus mu, standard deviation over square root of n. And step 5, we calculate the what? The decision or conclusion. So if you're given your now hypothesis on step 1 as mu is equal to 10, and here mu is not equal to 10, then you're given your X bar 15. Just using arbitrary figures so that you understand the concepts. And here you're using standard deviation, which is equal to 12. Your sample size is 36, and your alpha is 0.05. So step 1, state the hypothesis, which we have here. Step 2, state the level of significance, which is 5%. Step 3, state the decision rule. What is our Z at 5%? 1.96. 1.96. Why? The sign here is what? Greater, equal to, or not equal to. So we say reject what? HO. If Z calculated is what? Greater than 1.96. And step 4, we calculate the Z. What is our Z? X bar minus mu over standard deviation root of n. So here we have 15 minus what? 10. Standard deviation is what? 12 square root of 36. What do we get? 5 over the standard error is 2. Because 6 into 12 is 2. So 2.5, when you put it somewhere here, it's in the rejection region. So what is our decision? At 5% level of significance, what do we do? We reject HO. Why? Because our Z calculated is greater than 1.96. All right. Are we following? So I've covered this, I've covered this, I've covered this. So I'm going to substitute this with hypothesis. Are we together so far?
Yes.
Let's look at the single tailed test, then I go to the professor question. So here, suppose we're insert given our HO, mu is equal to 10, mu is greater than 10, our alpha, our n is 49, our standard deviation is 14, and our alpha is 0.10. So tell me, what is our tails? Is it a single tail or a double tail?
Single tail.
Pardon?
Single.
What is our level of significance?
99, 90, 10%, 90.
And what is our Z? What is our decision rule?
What
What is our Z?
Um,
1.28. It's a single tail test. If it was a double tail test, what will our Z be?
was it 1.645?
So here you're going to reject HO if our Z calculated is greater than what? 1.645. We're going to shade on one tail only because we're on this side. Then step 4, we calculate Z. What's the formula for Z? X bar minus mu, standard deviation over square root of n. So here we have what? 15 minus 10 over standard deviation is what? 14
14.
over square root of n, which is 49. So here we have 5. Our standard error is what? 2. Here we get 2.5. So 2.5 is in the rejection region. So what is our conclusion? Reject HO. That is a conclusion. Are we together?
Yes.
Okay. So now let's go.
So honestly, for me, I don't. I've not mastered on how to tell the between the one-tailed and the two-tailed test.
Tailed is a science. The single tailed is equal to or not equal to. All right. The words greater, less than, all those are pertaining to a what?
Single tail.
Yes, equal to, or if it's silent, that is pertaining to what? Double, yes.
Two tail.
That's the only thing that you need to know. Okay?
Okay, the greater or when it's silent.
Yes, when it's silence, yes.
Okay, so when it's greater or less than, then it means it's one-tailed.
Yes. When it's greater or less than, it's a single tailed test. Okay. Any other questions on that? Any other question? Before we look at the question, have you seen the question? Okay, so we're going to look at the question on the professor. Then we can deduce whether it is a single-tailed or it is a double-tailed test. Okay. So let me beam the question, but I've sent the question through. So let's answer it objectively and with much thought. Okay. So I'm beaming it just now. Okay. So there we go. A professor claims that the average size at an university is greater than 35 students because a random sample of 18 classes contained 3.81 students. That is just a claim. Assume the population is normally distributed with standard deviations 7.6. But 1 at 0.05 level, calculate or test. All right, so let's digest this question. What are we given there? Let's digest this question. What are we given there?
Mu is 35.
Mu is 35.
N is 18.
N is 18.
Then the other mean is 38.1.
Mu is 35. Meaning the alternative would what? Greater.
Greater.
Guys claim that the average is greater than that. 35. So this is a single tailed. Z is what? 0.01. Okay. This is 99%. So we have what? 2.33, not 2.58 because it's a single tailed test. Our N is what?
18.
18. Then our what? Standard deviation is what? 7.6.
7.6.
So let's conduct step 1, the hypothesis. Mu is equal to what? 35.
35.
And mu is greater than what? 35. Step 2, set the significance level. This is what? 1%. Step 3, the decision rule. This is greater. We're going to look at this right side. So what are we going to reject? Reject HO. If Z calculated is greater than what? 2.3.
2.3.
And step 4, calculate the Z is X bar minus mu over standard deviation root of N. So here we have what? X bar was calculated from a sample of 18 people. So N is 18, and X bar is what? At 8.1. Okay. So what is our standard deviation? 7.6. Square root of n. N is what? 18. So what becomes our z calculated? What is our z calculated? 1.73. 1.73. So what is our conclusion? 1.73 is inside there. So what do? We accept H bar. You can also calculate the p-value of 1.73. Checking the table 1.73. What do we get? 0.9582. 0.9582. So to use a p-value, when our p-value is greater than alpha, we reject. And p-value is less than alpha, we do what? We fail. For the p-value, it's opposite. If the p-value is greater than alpha, we reject. If the p-value is less than alpha, we fail to reject. We can use any two methods, using the p-value or using the alpha method. So here, we go to our Z table, 1.73. Let's go to our Z table. What is the figure for 1.73? So 1.7 and under 3, what is the reading? 1.7 under 3, what do we get?
0.9582.
0.9582. So subtract 1 minus 0.9582. So the p-value is greater than alpha. What we do? It's the opposite for the p-value. We
Reject.
reject. If the p-value less than alpha, we accept. Okay. So when the p-value is greater than the alpha, it's the opposite. You're confusing me. If p-value is greater than the alpha, we accept. If it's less than the alpha, we reject. Okay. So here, why are we accepting? Because our z value is inside there. The p-value is found there. So our alpha at this point is 0.01. So let's calculate what is 1 minus 0.9582. 1 minus 0.9582. What do we get? 0.0418. 0.0418.
I'm kindly asking if we can go back on how we found the p-value.
On the z
From
value,
behind.
are we together first of all on the z value?
Yes, there I'm okay. Now on the PV.
Okay. So on the PV, it's the opposite of the z. So if PV is the p-value is greater than the alpha, what do we do? So whereas the z, we just compare them like this. If the z calculated is greater than the z statistic, what do we do? Reject. If the p-value is greater than the alpha, we accept. They just work in opposite. If the Z calculated is less than the Z from the table, we accept. If the p-value is less than alpha, we reject. How do you get that so far? On this note, are you following? So in this case, we found what? Our Z value at 1.74, all right, which was less than our 2.33. What was our decision? We rejected. It must be the same decision here. Okay. Oh, there's the same decision here since we're accepting here. So when we weighed the 1.74, we got 0.95, or 0.9582. All right. Then subtract from 1. What did we get? 1 minus 0.9582. What did we get? 0.9582. We got what? You're not participating, so it's difficult for me to explain. 0.0418.
Yeah, following.
0.18. Which is the same as 4.1%. So we're going to compare 4.1%, okay, against 1%. Is it greater? Yes. So we're going to accept. So using the p-value, that is a formula we use. All right. Are we together?
So Mr. Collins, so when we're using the p-value, we subtract that one, we are getting it from the significance level.
Yes, significance level. We're getting it from the significance level, yes.
All right, okay.
Because the question, I needed the p-value because the question was specific, use the p-value. So if it's specified, you are tied. So this is how you use the p-value. All right. Any questions? Any questions so far? So I indicated this in the miracle kit that you understand better on how the p-value is done. But I think I've explained it more elaborate now so that you can follow through. So here's a question, same thing that I've done, right? So our mean is 35. Mu is greater than 35. Z was 1.73. And you read it, the critical value you find here, since it's a single-tailed test, 2.33. Then since Z is what? Less than 2.33, we reject. We don't have sufficient evidence to reject the claim. But using the p-value, because the question was in 2 parts. Okay. The question said, let me just put question from the doc. Okay. So the question says part B, verify your claim using the p-value. So that is why we are verifying the p-value. We use 7.3. So the lower part, so since it's 7.3. So when we get this one, we read it to be the amount we subtract from 1, we get 0.3. Then we're going to compare the 4.18 against 1%. So since it's greater, there is insufficient evidence to support the claim. By accepting, it means we don't have sufficient evidence. All right. Unless there are any questions I've left out from the weekend classes that the doctor did, I think these are all the questions. I have answered all of them, isn't it? Are there any questions that I've left out? These are all the questions that okay, there's one more.
Mr. Collins, I thought in the one that we were doing we accepted, but here I'm seeing rejected.
No, we accept. Rejected alternative hypothesis HA. This is HA. It's accept. This will be we fail to reject. We have insufficient evidence to support the claim. So whenever we have insufficient evidence, we accept. Okay, so this is H1. We accept. Okay, we'll look at the last question, I think, on the CEO. The last question on the CEO. Then we end our day. Okay. Have you seen the question? Have you seen the question?
Yes, sir. You people are making noise there.
Can somebody read the question? So we're told that a CEO of a life insurance company wants to do it, to undertake a survey of a huge number of insurance policies. And we are told that the company makes yearly profit on each policy that is distributed with mean of 500 and standard deviation 300. It is desired the survey must be large enough to reduce the standard error to no more than 1.5% of the population. How large must sample size be? Who wants to try? What are we given? What have we been given in that question?
We've been given mu and the standard. Is it the variance? The standard deviation of 300.
Okay. We've been given mu. We've been given standard deviation. Okay. So what are we being asked for? What is the question asking for?
To find the population.
We're being asked to find the population, correct? The sample size. That's what we're being asked. Okay. So what formula are we going to use? Formula we're going to use. We have a sample size formula. Going to beam the question so that we're together. Here it is. Are you able to see it?
Yes.
So we're given that question. What are we given there? And what format do we use? Sample size formula. What's the sample size formula? This is just the last question. Should I leave it as your homework?
No, sir, just go. Yes.
Okay, so let's go through the question slowly and critically. The CEO of a life insurance company wants to undertake a survey on the number of insurance policies that the company has underwritten. The company makes a yearly profit on each policy that is normally distributed with a mean of 800, and standard deviation is what? Our standard deviation is 300. It is desired that the survey must be large enough to reduce the sampling error no more than 1.5 of the population. In how large must the sample size be? All right. So we need to understand the formula of sample size. I've given you the formulas for sample size. So what formula do we use for the sample size?
N is equals to S squared, Z squared. Is it? No. I'm mixing things.
It's actually is it A squared? Yes. Okay, let me try. A squared times Z squared over A squared.
Yes, correct. I was almost ending the class because I was getting discouraged. All right. Let me clear my board since my slides are exhausted. I only have 12. So N is equal to what? Z squared, S squared over A squared. So what are we given in this question? Let's itemize what we're given.
We've been given standard error estimate. We've been given the standard deviation. And also the mean that we've been given.
Okay. So what is the formula?
So is it that
What's the formula for standard error? Standard error is given by what? Sample size over square root of n. I gave you this, right? Huh? Then our standard error, we're told that, what is our standard error? What are we told?
1.5.
1.5.
Standard error is 1.5% of what? The population mean.
Population mean.
So what is our population mean?
800.
1.5% of 800. Okay. Then what is our standard deviation?
300.
300.
Standard deviation 300. And what is our n? We don't know. So what is 1% of 5% of 800 is what? 12.
12.
Okay, then to find n, cross multiply. So these ones are just swap positions. Square root of n is 300 over what? Over 12. What is 300 over 12?
25.
25. So meaning what's the square root of so square root of n is 25, meaning to remove the square root to square both sides. So n is what? 625. So these are the numbers that we need, okay, for us to be sure our n is what? Our n is 25. All right, is that clear?
Mm.
We want to use this formula, we can't use it because we don't have a z. So the standard error, it's important, that's how I was explaining. To say, what is standard error and what is margin of error? For those who remember, what did I say was the margin of error? Z standard deviation over square root of n. So the margin of error is simply z times the standard error. That is how we find the margin of error. All right, so we have answered our question, isn't it? So how large must the sample size be? So the sample size must include 605 policies. All right, 625 policies. So so this is how we get our answer correct. So we're done now. I must hope the online classes have gotten a good chunk of the variety of the questions.